All right, welcome to synthetic division, the next level in our polynomial division and factoring endeavors. Here we have a cubic four-term polynomial, and we're dividing by a linear x plus 5. Now, the nice thing about synthetic division is it saves us the long process of long division by just working with coefficients, but it only works with linear division of a linear. And so what we want to do, it's an algorithm, it's a weird process, kind of strange. First thing you do is you take what you're dividing by, the linear x plus 5, set it equal to 0, and solve for what x-intercept it would cause for this polynomial. And so, if it works anyway. And so we get to subtract 5 from both sides and get x equals -5. Now, what I was trained to do when I was young was you put a little bracket guy there, kind of a half box. My teacher called it a hockey stick. I was a hockey fan, apparently. Anyway, then what you do is you take this x to the third plus 6x squared minus x minus 30, and you take all the coefficients. You just strip it of its variables and just bring down coefficients to just the 1. That's the number in front here. Just the 6, just the -1, and just this -30. It's kind of weird. It's numbers in abstract with hopefully some space between them so it doesn't look like one big number. And then we put a math bar. And the algorithm goes like this. It's just a process. You always take the first number straight down below the math bar. And then what you do with it is you multiply by this number over here. So it's a product of this number at the bottom with -5. The result goes underneath the next coefficient. So 1 times -5 should just be -5. That goes directly underneath that next coefficient, and then you add. So 6 plus -5, so 6 minus 5, gives you 1. And then everything after that is repetition. You just repeat the exact same process. You take the 1 all the way back here, multiply it by the -5, take that result right back, and put it up underneath the next coefficient, which is -5 again. This time, we add two negatives together to get a -6. And then, one last time through, we repeat the process. We take -6 all the way back over here, times it by that -5, and get a +30. And then, to finish, you add the coefficient above it, and that gives you a 0. Now, that 0 is awesome. It means that we have no remainder. This is the remainder box. The last number is always the remainder. In this case, the remainder is 0, which means that x plus 5 is a factor of this cubic polynomial. Now, that wasn't the question we were asking. It says, hey, find the result of division. So what we did was we took a cubic function and divided it by a linear. If you took a cubic and divided it by a linear, a single power, you would get a x squared result. So essentially what we do down here is we take 1 degree off that power and bring down a variable. These are the coefficients for my answer. It's 1x squared, 1 degree lower, and then you keep filling in the next degree down. So this is 1x to the 1, and then minus 6x to the 0, and then plus your remainder. Now, you didn't have to write that plus x to the 0. I just wanted to fill the pattern. The answer is x squared plus x minus 6. This is the result of division. Had I done long division, this is what I would have got. Now, again, I said over here that this is a factor. What it means is that I could write that answer times x plus 5 as a factored form for, with parentheses, for x to the third plus 6x squared minus x minus 30. So had I said, hey, factor this, if maybe it factored by grouping, which I don't believe it does, the factored form would look like this. So this long division process does two things for us. It gives us a way to do division, perform division, but it also produces a further factored form of polynomials, which allows us to later factor down and set it equal to 0 and solve. Perhaps we'd have to do a quadratic formula, or maybe this would factor. But again, that wasn't the point. That is the result of our division. So in our first example, we had a perfect scenario where everything worked out. So let's see what happens this time. First thing I want to do and start paying attention for is that my degrees go down perfect descending order. Now that is not the issue for this example because it is perfect descending order and we're dividing by linear. So we can go ahead and complete the process here and see what happens. We get x minus 2. You need to set that equal to 0. That's your first step. And then you solve for x as if you were finding for where this would cross the x-axis if x minus 2 was an x-intercept or a factor. So we get x equals 2 and put that in a little half box and then bring down all your coefficients. So we got 2, negative 3, negative 11, 21, and negative 6. Give yourself a little space and a math bar, just enough space for some numbers to fill in the gap there. And then you bring down the first term always. First coefficient just comes straight down. And then the process is you're multiplying these numbers by the number in the box and putting the result underneath the next coefficient. The next coefficient gets a 4 underneath it. 2 times 2 is 4. And then you add vertically, which is going to give me a 1. And it's just a series of repeating the process as accurately, as quickly as possible. So we get 1 times 2 gives me a 2 here. And then we add vertically with the 11 to get a negative 9. And then we take negative 9 and 2. Draw my little arrow over there. Negative 9 times the 2 to get negative 18. Then you add there, and we should get 3. Final step, take your 3 times your 2, and that gives us 6. So my answer in the box over here is 0. That box is my remainder box, and what it means is that x minus 2 is a factor of this quartic polynomial. Now, we have no other factoring technique for this quartic polynomial, so we wouldn't have been able to do any factoring except this division process. Now, we could have used long division, but anyway, the idea here is we had a quartic, x to the 4th, and we divided by a linear, and so 1 degree less is going to be the result, x to the 3rd. So you take this x to the 3rd, 1 degree less of the 4, and fill in a variable, starting with the cubic, and then all the way down. So we say plus 1x squared, and then minus 9x to the 1, and then plus 3x to the 0, which you didn't have to really write, but all the way down to 0. And then our final answer of division is 2x to the 3rd plus x squared minus 9x plus 3. This is the result of division. And if I had asked for factored form, we would just put that in parentheses and then just say times x minus 2. That is the factored form of the original polynomial, 2x to the 4 minus 3x to the 3rd minus 11x squared plus 21x minus 6. But again, if I said factor, that would be the result. Here we just said divide, so this inside the box is what we were looking for, the result of division.